Dear viewers, welcome to another instructional video produced by Schoolnet Uganda. This video focuses on production of homemade liquid soap. This video on production of homemade liquid soap is aimed at providing you with the knowledge of the science behind production of homemade liquid soap, the detailed steps involved in the production of liquid soap, the chemicals used and the functions of each chemical used in the production of liquid soap, and the safety precautions that are taken to avoid possible health hazards and those that are needed to ensure that the liquid soap produced does not either cause skin burn or skin irritation. My name is Mbubu Abdalah, a chemistry teacher and your facilitator in this video. And with me is Elizabeth Nazwa, a student and my co-facilitator, who will be practically demonstrating to you the steps involved in the production of liquid soap. Production of homemade liquid soap is an interesting, educative, and economically viable activity which we teachers, especially chemistry teachers, can engage our students in to show how the chemistry learned in class is applied in daily life, thereby bringing reality to classroom work. Also, students, teachers, out-of-school youths and parents can engage in production of liquid soap to raise income to meet their basic needs, because the production process requires little starting capital, takes little time, and it has ready market in homes, schools, offices, and car washing bays. The following chemicals, which are easily available on the local market, are used in the production of liquid soap. The functions of each of the chemicals used will be explained later. These chemicals are sodium lauryl ether sulfate, commonly called Wungarol, or just SLES. Sodium chloride, also called common table salt. Sodium hydroxide, also called caustic soda. Sulfonic acid. Sodium carbonate, also called soda ash. Ethanol. Cocodiethanol amide, also called CDEA or KDS. Urea. Water. Water soluble dye, which we call the normal food color. Benzalkonium chloride, which we call the normal preservative. The pH paper, and perfume. The following implements are used in the production of homemade liquid soap. A mingling stick, which is wooden, a 20-liter jerry can, a bucket, a plastic basin, a spoon, a measuring cylinder, and a plastic cup. Some of the chemicals used in the production of homemade liquid soap, like caustic soda, soda ash, urea, and sulfonic acid can cause skin burn, eye damage, digestive and respiratory tract irritation and damage. It is extremely important that you use proper protective equipment as you mix the chemicals when producing homemade liquid soap. Wear chemical safety goggles to avoid damage to the eyes. Wear mouth and nose mask to avoid digestive tract and respiratory tract irritation and damage. Wear industrial gloves to avoid hand exposure, and wear clothing that prevent direct skin exposure in case some of the chemicals splash out during the mixing. Before going into the practical steps involved in the production of homemade liquid soap, it is important to us to understand what ingredients are used in the production of homemade liquid soap. Production of homemade liquid soap involves mixing a number of chemicals, starting with ungarol. Ungarol is used as a starting material because it is cheap and a very effective foaming agent. It is a surfactant, and surfactants lower the surface tension of a liquid. It adds viscosity to liquid soap. The following ingredients are then added to ungarol to produce liquid soap. Water. Water dissolves the various ingredients to mix better. A hydrolyzer to keep liquid soap a liquid. A preservative to kill the bacteria, fungi, and yeasts so that the liquid soap can last longer. A perfume to make the liquid soap have a pleasant odor, and also to cover up the smells of the other chemicals in the mixture. A stain remover to remove the stains, e.g. oil, grease, from what is being cleaned. A dirt remover to remove the dirt from the skin, clothes, and other household articles, particularly in kitchens. A thickener in order to make liquid soap thick. pH is a measure of how acidic or alkaline a solution of a substance dissolved in water is. The pH scale runs from pH 0 to pH 14. Acidic solutions have pH values less than 7. The closer to pH 0 you go, the more strongly acidic the solution is. Neutral solutions have a pH of 7. Alkaline solutions have pH values greater than 7. The closer to pH 14 you go, the more alkaline the solution becomes. The pH paper, when dipped in a solution, changes color based on how acidic or alkaline the solution is, with red for strongly acidic solutions, green for neutral solutions, and purple for strongly alkaline solutions. Wear protective clothing mouth and nose masks, and safety chemical eye goggles to prevent eye damage, skin burn, respiratory and digestive tract irritation and damage. Pour 1 kilogram of wungaro into the plastic bucket. First, you are going to add sodium chloride, commonly called table salt, to the wungaro in the bucket. Sodium chloride will soften the water, help to keep the liquid soap from drying, and also preserve the liquid soap to last longer. Add 1 kilogram of sodium chloride to the wungaro in the bucket and stir the mixture continuously with a wooden mingling stick for about 25 minutes until the mixture turns milky. Next, you are going to add caustic soda to the mixture. Caustic soda will act as a dirt remover in the liquid soap. Caustic soda is highly alkaline with a pH of 14. It is very corrosive and can cause severe irritation, skin burn, and damage to the eyes. Always wear safety goggles to protect your eyes and cover your mouth and nose with a mask when working with sodium hydroxide. Add half a kilogram of sodium hydroxide to the mixture in the bucket. Stir continuously for about 5 minutes. Next, you are going to add urea to the mixture in the bucket. Urea is added to the mixture to make the liquid soap thick. Add half a kilogram of urea to the mixture in the bucket and stir continuously for 5 minutes.